Hey everybody, Cole here with Classic Mini DIY, and on today's episode, it is finally time to finish the assembly of this beautiful 1100 long stroke high compression engine, and I have some really exciting upgrades to share with you guys today. So, you won't want to miss it. Stay tuned for that. Now, as I mentioned, we are going to really finalize and completely assemble this 1100 engine today. This is going to be a little bit longer episode, and it's going to be a fun one. So we just got the cylinder head back from the machine shop, and as you guys can see, it is absolutely beautiful. We went with a combination of specs from Keith Calver, AC Dodd, and Russell Engineering down in Australia. I used all of their expertise in the forms of their documentation that they've written over the years to formulate the best size valves and really the best performance we can get out of this 1100. What that looks like is an enlarged intake and exhaust valve. We've added flat top pistons to this engine, and we have done a little bit of porting and polishing in the inlet runners and in the exhaust. So with all of that, we're gonna have a really great 1167cc engine here with a wonderful compression ratio that will be able to keep up with those 1275s. So what are we doing today? Well, what aren't we doing today? We're going to be installing the tappet covers, the cylinder head, the push rods, the timing cover, the gearbox, the drop gears, the flywheel. We're going to do it all. So I want to show you guys some really cool upgrades that we have decided to add to this engine. We'll get to those as we start assembling it. But first, let's take a look at the cylinder head and get everything prepped on the top of the block here so the cylinder head can go on and be nice and happy. Hey everybody, Cole here from the future, and I wanted to stop real quick and let you guys know that I made this video a little bit differently than I have in the past. This video is the technical version of this video. I have also done a supercut of only audio, so only music, and the video time-lapsed for this whole engine build. So, depending on what you guys like to watch, I've got two different versions for you. This heavily technical video, which I'll talk about all of the stuff that I'm doing, and then the simpler audio and video only episode. Let me know what you guys think of this. If you want me to do this kind of stuff in the future, probably won't be for every video, but in the future, it is definitely something that I could see myself doing. So, curious about your feedback, let me know, and I'll get you back to your originally scheduled episode. Thank you so much. See ya. If you've been with the channel for a little while now, this isn't going to be the first time that you've seen me put a cylinder head on an engine. But to recap, the most important thing here is that we have a nice, clean deck face here, which I've already done a pretty good job of keeping this clean as we've been going through it. But it's going to be really important because we don't want any chance for head gasket failure or any issues where we have leftover debris in here, like this little rag that keeps tearing. And on my last episode, I did have a question about the studs here. So we are using ARP cylinder head studs. These I swap in on every single build. Honestly, I don't see any reason to use the factory ones. These are far superior, and honestly, it's worth a little bit of money for that peace of mind. Now, there's two different ways that you can install these studs. One is with thread locker, and one is without. ARP does say that you can do it either way. And the most important thing is, whichever way you choose to do that, you need to make sure you look at the instructions, because what they say is if you do use thread locker, you have to torque the head down before the thread locker dries. So you have to torque it to its spec before the thread locker dries inside these little holes here. Personally, I do not use thread locker on this. There's no real performance or detriment to not using thread locker here. And if you look at the instructions on this, the key is get these hand tight So nothing too crazy. You're not blasting the hell out of these with torque. The torque comes on these threads on the nut that you're putting on the end. That's what's pushing and squeezing down the head onto the block. One thing you'll notice over here, this is a little bit different than the later cars. Earlier cylinder heads had something called a bypass hose that allows coolant from the head to bypass essentially all of the other setup here and go straight back into the water pump. I am going to preserve this line. This has a little bung on the bottom side of the head, and we just need to measure this because it is, I think, a little bit too long. Now, I do want to stress that this is something you really, really will want to replace on every build. This hose is a real bastard to get to when you are, when the head's in place. And so anything you can do to kind of make your life easier in the long run is definitely something I recommend doing. So we'll go ahead and put this hose clamp on here, slide that down. And now I'm going to just loosely set the head on here with the head gasket and make sure that the length of this hose is correct. So with that, we've got that confirmed. The head gasket is in. I don't actually have anything that I need to remove from the bottom of the head. I've already cleaned this up. So what I'm going to go ahead and do is set my lifters in here, and then we'll start putting the rockers on and then tightening it up. Now you'll see just down here that I have already put in my lifters. And these are what rest on the camshaft and are moving up and down to move the push rods that sit up in the top up and down. So they go all the way down through. This is something that's unique to the earlier blocks. In the later blocks, they did away with these open covers. It's just one more place that they leak. And it's not really necessary to be able to access those all the time. So we'll go ahead and leave that one in there, and we'll go ahead and install the rest of our push rods. And now we're going to install a really, really cool piece of kit, and that is our forged 1.4 rockers. Now you'll see they have these CNC'd steps for actually holding it down to the head, but they are using the factory rockers here, and each of the tips are a little bit heat treated. From what I understand, they make these specifically to that 1.4 ratio. And it's going to be the perfect ratio for this naturally aspirated high torque and high compression 1100. Now what I would recommend doing, this is what I do on all of my builds, is the 4 posts that are actually holding the pedestals in place, I would suggest torquing those down first. These don't have any bearing on the head itself, and it's sandwiching onto the block. Specifically, they hold the rockers fully stabilized and down. One other thing that I would do is all of these rockers, I would loosen up these set screws and these set nuts so that they're wound all the way out. And this is going to put the least amount of strain on the valves and the push rods as you are torquing the head down. So going through and just simply rolling these out. Now normally you wouldn't be able to do these by hand in this way. The only reason we can do this is because it's a fresh set. These locking nuts haven't been wound in and locked in place. And we'll do that when we set the valve clearance, once the head is in place and where it needs to be. Now you may be able to see, maybe not, I'm putting a small amount of the ARP assembly lubricant on these. This is just going to make sure that the torque spec that we're actually torquing these down to is correct. This is definitely vital as we're doing these. This is going to help you, this is going to help the torque spec be absolutely perfect for these. And these pedestal nuts from ARP don't get torqued to the same amount as the cylinder head itself. The cylinder head gets about 45 foot-pounds. These are just up to 25 because they are genuinely just holding the rocker assembly in place. So I'm going to run these down by hand get my torque wrench out, get them torqued. And now we are going to start torquing down the actual head studs. Now the head studs do have a specific pattern, and we'll go ahead and get all of these torqued down to their necessary 45 foot-pounds. And everyone has a slightly different opinion about this, but for me, the way I like to do this is to obviously use the pattern that's recommended by BMC. This is in your Haynes manual for operation and the first heat cycle. What I like to do is torque all of this down to the 45 foot-pounds, and then after I do a full heat cycle in the engine, I actually come back and re-torque them just a little bit up to 50 pounds. That has worked pretty well for me over the years, but again, just like everything, everybody has a slightly different opinion about this, so use your best judgment. I have not had an engine have any issues with doing that method. Now, as you're hand tightening these, you're going to want to take care. Just keep an eye on your push rods. Make sure that they're all still seated correctly. Make sure they're not askew, nothing's popping out, because obviously those are very important that you don't want to bend them. Otherwise, your car's not going to run right. It's going to change when the exhaust or when the intake is actually firing, which is not what you want. Not what you want at all. This next part is something that I have been dying to install. I absolutely love the look of the rear tappet covers on these original Minis, but they are notorious for leaking. There's essentially what used to be a big cork gasket that went around here, and those leaked like crazy. Then they added a nice new rubber one that you could get to replace those cork ones. However, they like to kind of fold in on themselves. Well, Specialist Components came up with a nice new CNC'd version of these, and we're going to be using this on this engine just for that reliability and longevity, because while this is a very original engine, we're putting a lot of new stuff on it, and the engine itself is going to be in a daily driver. So we want this to be reliable. We don't want it to leak. And you can see here on these covers, they've got a built-in O-ring, and then the bolt with this kit comes with an O-ring built into the washer. Very clean, very tidy, and I am super excited to put these on the car. So let's go ahead and install these. Now, as you may remember in the last episode, I didn't put this cover on because I had not painted it yet. More specifically, it had not gotten back from the powder coater. So we're going to go ahead and put that cover on. We're going to take our little captive nuts here off. This is a timing plate cover from Swift Tune, who also made the rocker assembly that we just put on. This kit is really, really nice. Honestly, can't say enough good things about it. All right, so now we are looking at the brand new flywheel. This is a Mini Spares flywheel. It's one of their lighter alloy models. This is a pressure plate from MED. Goes on like that. And then the diaphragm goes on the other side. So what we want to do is make sure that we are assembling this exactly the way it needs to be assembled, and we want to centralize this on the primary gear. So when I have the opportunity with the engine out of the car, I like to kind of soft assemble this so that we can see how it feels, how it looks, how it mates up, and kind of centralize it and then torque everything down. So got these two pieces here looking pretty good. We're going to flip this over, holding everything together. You can see also, I didn't show it, but but you're going to want to clean the surfaces that touch the clutch. If they're oily, you're going to foul your clutch and it's not going to work right. So I'm going to flip this over, taking care. You can see these earlier style clutch and flywheel setups, kind of finicky. All right, so once you have this in place, the next step is to grab one of your spacers. Go ahead and set that in place. And I'm going to go ahead and set the spacers in place for all of the holes just to make my life a little bit easier. And we're going to take our straps. We're going to take 2 on each one and apply them here. Go ahead and set them in place. And now on the Verdo clutch, this is all kind of one built assembly, and it uses a more modern style spring. This is a pre-Verdo clutch, which uses a spring diaphragm. You can see this raised lip. This is what's giving you that pressing force, and this is essentially your clutch spring. So what we're going to be doing here is setting this down in place like so. And you'll notice the turrets or the horns of your pressure plate that's on the opposite side of the flywheel are sticking up through these holes. That's what's going to line up and mount these bolts here. So we're going to take our longer bolts, and I'm just going to go ahead and get these started. Now I've already applied blue thread locker to all of these. I like to use thread locker because it is the modern century, and thread locker works a little bit better than spring washers do in some situations. In this case specifically, this is a spinning apparatus, and so with something that spins, spring washers can actually come undone pretty easily. You might be looking at this and saying, Cole, wait a minute. How do you get access to the bolt to actually tighten down the flywheel? Well, this little cover right here can actually come off. We'll take our little spring retainer out here, just like that, and that just pops right out. Ba-ba, just like that. So go ahead and set that off to the side. I'm gonna bring these down hand tight, not super, super tight, but enough that there's, you know, kind of held in place. And once they're there, we're gonna go ahead and set this on the engine and use the engine to centralize the whole clutch, disc, diaphragm, the whole kit and caboodle. And then once it's on the engine, just setting down on the engine, not fully torqued in place, we'll tighten all of these 6 bolts, which will then hold everything exactly where it needs to be. Okay, so to clarify what I'm talking about is you can see this pressure plate on the back here and then your flywheel on the front. That sandwiches the actual clutch disc, and what I want is this to be just loose enough to where this can move around a little bit, because we want to centralize that before we torque it down. This is just going to make sure that it's nice and easy to put on once we assemble the bottom half of the engine. So with that loose, I've got my 6 bolts in place. Let's move over to the engine and set this down. All right, and so we have our primary gear on here. I've already set the end float. I believe I did that in the last episode, but you can see I don't have the drop gear housing on. I don't have the gearbox on, and that's okay. We don't really, that part doesn't matter so much right now. We'll go ahead, make sure we line this up. And you can see what I'm talking about. I've got to rotate that to make sure that this goes down nice and happy. So we're not fully seating this right now, but it does look nice. Everything is mounting up really well. And actually, let me show you guys the back side of this. It's not something you often get to see. So this will kind of give you a look at what it looks like with, normally you have your whole housing on here, and this is where your rear main seal sits and your primary gear here, spinning that clutch disc. And so you can see what's happening is when you have the clutch pressed, it's actually essentially opening this up so that the flywheel and the primary gear, things can spin independent of each other. So this would be able to spin around inside that space just freely, not contacting anything. And as you release the clutch, what's happening is that diaphragm is pulling this pressure plate closer, or rather releasing the tension on it, and that grabs your clutch disc. And when it grabs the clutch disc, that is when the whole flywheel starts spinning, and it starts spinning in conjunction with your crankshaft. So the whole idea is when you're making gear shift changes, it allows you to isolate the power, the spinning rotation of the engine from the gearbox, so you can make that other gear selection. Pretty interesting, really cool kind of technology behind this. Now, if you haven't used it before, I do have an online toolkit that you can use to quickly get access to torque specs. So you can see right there, big list of torque specs, and we'll get our torque specs for the clutch here. And these strap bolts, we'll go ahead and tighten all of those up and we'll be good to go. All right, and with that, we are ready to put the gearbox on, which is a really exciting moment. A little scary, of course. With a new build like this, you're always afraid to cover this space, be done with it, but it's time. Checked all the torque on everything. Everything's really happy, torqued up just the way it needs to be. And so all that's left is putting our new gaskets on, which we'll go ahead and put in place. And you'll want to make sure that you have identified where the bolts are for all of these holes, because finding those while you're waiting for gasket to seal is nerve-wracking. We want to put our half moon seal in right here. This is a notorious place for the Mini to leak. Annoying place. It always leaks here. I have tried millions of different things, but for some reason, it always finds a way to leak there. Now, one thing you absolutely do not want to forget is the rubber O-ring that goes in this space right here. This is one of the #1 reasons I see when people are doing these engine rebuilds for reaching out to me and saying, hey Cole, I have no oil pressure after I did an engine rebuild. Why is that? It's because they forgot this little teeny tiny O-ring for your oil pickup. So the way I like to do this is make sure this little groove is clean, and then after you've done that, get a little bit of gasket sealer to stick that down in place so that when you flip this gearbox upside down and set it down on the engine, assuming you're doing it the same way as me, it doesn't fall off. So just a little quick tip for you guys. So with that, we go ahead and put our gasket sealer on our paper gaskets, setting these down on the engine. I also put a little bit on the half moon seal, which I put on the gearbox side. I found that to be a little bit more successful. And then we lift this whole gearbox up, rest it down on the engine, and there we go. All right, so the gearbox is set in place. Now it is time to go through and attach all of our little bolts. Tedious, but very important. Now, one tedious, time-consuming thing that I do that's really probably not necessary, but I do like it, is you see this little bit of the gasket that's sticking out. That always seems to happen on the front and the back, no matter which gasket kit you use. It just seems to be part of the deal with these paper gaskets. You'll also see it on this end right here, where the face of your drop gear housing goes. This you'll definitely want to trim off, but I like to do it on the front as well. Just take a little razor, and once you have it torqued down, just run it along this line here. And in my opinion, it just makes it look a little bit nicer. It's the little details, but once this is all cut off, you have two faces that made up really, really nice, and the gasket that doesn't stick through. Now you can see it a little bit more clearly now that I've moved the camera over, but this is the face that your drop gear housing goes on. And these little excess bits will actually cause leaks if you don't trim them off. So just take the 6 seconds it takes to trim these off, because you'll save yourself oil puddles in the garage in the future. Now we'll rotate the engine back over and put the timing cover on. Our idler gear connect essentially the primary gear to the engine. Pretty exciting. Now, one thing I can't recall is if on the last video, if I covered setting the end float for your primary gear as well as setting the end float on your gearbox. I don't think I did, but there are 2 idler bearings, but there's 2 idler shims, one on each side of your idler gear here. And go ahead, set that down in place there. Now, these shims set a certain amount of end float from the gearbox, and it's really important that that's correct. If it isn't, you're gonna get play in this idler gear, and it's kind of play like this way. I'm exaggerating it, but what that does is eventually will wear down your idler gear and can cause failures in this space. So setting that spec ahead of time, very important. You do that when the gearbox is off. So if I didn't cover that, I'll check my old videos, but if I didn't cover that, sorry about that. I have done it in other videos. Now, when I set my idler spec, I accounted for a little bit extra, only because I know that I put this gasket goop on my builds. And so this gasket goop does add a little bit of thickness. It is material. It is a material that's going to be sandwiched in between these, but it is going to add a tiny bit of clearance. So you want to account for that when you're speccing out your idler shims. One other thing I do on all of my builds, this bearing and the accompanying idler bearing on the gearbox side, I replace those, as well as this roller here. This roller is mated and toleranced to the race that comes with it. It's a little kit. You always have to replace this race when you replace this idler. Now, you shouldn't have to force that on. If you are forcing it, there is something interfering with it. And more specifically, it's almost always one of the two bearings. And so if you force it on there, you're going to crack this housing. Okay, so let's talk rear main seal. There's two parts to this tool. You can see here, this is a tool for mini spares. And the way that it works is you are essentially protecting your seal from the harshness of those gear faces. And then this actually screws down. I have my bolt in here already, and it presses the rear main seal in place. Now we do want to be careful. Even when using this tool, it is possible to tear or mess up your rear main seal. So this face right here, very smooth. We're going to apply a thin coating of the engine oil that we're going to use to this. And then we're going to also apply some on the inside here. Really, you can use just about any oil that you have laying around, but I prefer to use engine oil because it is pretty thick for these engines, for better or worse. So we're going to go ahead and apply some to the seal here as well. This is just going to make sure that it slides nicely onto this face here. Now you'll see I got to shift it kind of a little bit to squeeze it on there. And we'll go ahead and press that in as best we can. And like I said, once you've done that, all you do is take your other part of the tool here and you'll screw it in place. And that is going to slowly press that seal in. Now, usually you can do this by hand. Sometimes you'll need to use a tool. And you essentially go until this base right here. Let me just zoom in and show you. You essentially go until this base fully seats onto the flywheel housing. So that's seated. You don't have to go master blaster tight here. Then go ahead, unscrew it, and we pull our sleeve out, and now you have an installed rear main seal. Now, one other tip I want to share with you is that while this is an early engine, which means that it is a pre-A+, it's a pre-A+ gearbox, it is a pre-Verdo clutch, and it is a pre-A+ block. There are some upgrades that we can take from the later models that are worth adding when you're building this engine. One of those things is a splash shield in the event that this rear main seal goes bad, which in reality it definitely will. These are one of the most notorious places for this to leak, and you can tell if you have a leak on your rear main seal by checking out this little cotter pin. this is also a common question I get when talking about these engines. Why is this cotter pin in this hole down here? Well, this is made to wick oil so you can visually see if there is oil inside your flywheel housing, and thus informing you that your rear main seal is leaking. Also, if your clutch is slipping, it's pretty obvious. So what I do is this little splash shield was only installed on A+ engines, but it does fit on the early engines. So I like to go ahead and install that. It is just a little safety measure to add a little bit of protection so that if that seal does go bad, or rather when that seal goes bad, it doesn't contaminate the clutch. All right, so we've got those 3 bolts in. Ran to the hardware store and picked those up. Next up, we are going to install our flywheel, clutch, and diaphragm, which I showed you just a little while ago, centralizing that. Now, you can see the engine is currently at top dead center. We've got this line straight up. We've got our C-clip on top, you can see here. This is intentional so that if we take this off, if we put the engine at top dead center, we know that C-clip isn't gonna fall off, or it's not gonna fall off while I'm putting this on. It's just a safety measure, but it's a little thing you can do to save yourself some heartburn in the future. So be careful. This is a finger pincher. Alrighty. Line that up. There's 2 different kinds of flywheel bolts. This one uses an earlier style flywheel bolt, and then of course there's a later one that has the washer built in. For this one, as I said, it uses the earlier style. Make sure we put this in the correct direction. Now from factory, this of course did not have any Loctite on it. Like with all of the other things I've done on this build so far, I am going to add just a little bit of Loctite on this. Just for that added bit of safety. I'm not gonna add a boatload. I'll go ahead and get that down in there, and we'll start screwing this on. Now the idea behind this little tool, it's nothing magical really. It simply holds the flywheel in place so that you're able to torque this down to the necessary crazy high torque value that we need it to be. That's torqued down. Now, there are little lock tabs here. I like to go ahead and bend those up, as you can imagine. Then we get to install our cover. But wait, we got to install our throwout bearing and our arm. We'll be using an uprated Preverto clutch arm. Now what that consists of is a flywheel plunger that looks something like this. You can see it's got a wider mouth, a throwout bearing that looks like this. This is usually regarded as the stronger type of throwout bearing. And then an arm that looks like this. This is the stronger uprated arm. This kit is from MED. And the way that this goes in, arm goes in, plunger goes through, and the throwout bearing presses on the clutch diaphragm, which is what actuates the clutch. Pretty cool stuff. So to get this all set up, we do need to press this together, which I'm going to do on my bench vise, and then we'll assemble this. All right, now you can see that's been pressed in, pretty straightforward, and you just want to make sure that spins nice and free, doesn't make any noise. If it makes noise here, it's going to make way more noise on the car. Go ahead and set this down in here, and then we'll rotate it so that the hole lines up properly with our new arm. And I like to add just a little bit of grease to the end of this. And then it's gonna come with a pin with a little R-clip. You're gonna wanna just line up the holes, just like that. And you can see how that actuates now. Pretty straightforward, nothing too magical about it. Now I'm gonna get you in on a little pro tip here. Don't install these 2 holes right here, these 2 bolts. The clutch, everything's gonna work just fine. But if you ever have to service this while it's in the car, these 2 holes missing is going to save you so much heartache and so much heartburn. It makes getting this cover off while it's in the car so much easier, and it turns a miserable job into just a slightly annoying job. Another thing I'm gonna go ahead and just place on here is our flywheel lockout nuts, our clutch lockout, I should say. This is going to prevent you from overthrowing your clutch, so pushing it too far. Now these are the bougie titanium bolts from MED. Now be careful with this. You aren't going to want to use bolts that are too long because they will contact the flywheel or the clutch diaphragm if you're not careful. Now some of your engines might have an opening right here, and this engine is one of those. With your engine at top dead center, this is another thing that I like to do as kind of a safety measure in the future. So we have a top dead center mark on the pulley on the other side of the engine, but sometimes that mark wears off, sometimes it gets hard to see. I like to add a mark here on the clutch diaphragm because that's what we can see here. And then I also like to add just a little bit of white paint, make it nice and visible. Now, that is going to set you up for success in the future, like I said, if the mark ever wears off on the other side of the engine. So finally, we're going to go ahead and install our slave cylinder. This is a pre-Verdo style slave cylinder. And then I am going to be installing this little solenoid. So this is something that's unique on this style of engine, which is an external starter solenoid. You can see it gets mounted and has a few leads to connect various different electrical items. Not all cars have this, but this car does. Moving on to the water pump, we'll go install the pulley, the fan, and then we will move on to installing the radiator. Pretty straightforward. I'm using a later radiator shroud because it provides a little bit more clearance on these early style cars, which means that in the future, if Jerry wants to, he can upgrade to a larger radiator if he finds that it is necessary. Then we'll install our distributor drive gear. This goes in, and then our distributor drive gear retainer. Finally, we'll get this bolt in here, and it's now ready for the distributor itself. Moving on, I'll connect the lower radiator hose, taking extra care to rotate this Jubilee clip so it's pointing upwards. This is going to make servicing this in the future much, much easier. And then finally, we have the finished product. Well, mostly finished before going into the car. We've got all of the different ancillary items that I like to install before dropping it in, all connected and ready to rock and roll. All right, so I think that is as good a place as any to cap this off. As you can see, we've got it essentially fully assembled, at least to the point where it's ready to go in the engine bay. My buddy who owns this engine and owns this car is going to be coming over a little later today, and we're probably going to go ahead and put this engine in the car. So I'll go over a lot of the stuff after we get it in there. I don't think I'm going to film that. We're just going to hang out and, have some beers and put this in. So if you guys have any questions about what I did on this engine, let me know in the comment section below. I really appreciate you guys joining me on today's episode. And on the next episode, I think what we'll do is once we get oil pressure, all the different things that are related to this, I will get a video of the car running. We'll go over the whole engine and we'll bring it for a test drive to get you guys an idea of exactly how this 1100 compares to, say, a standard 1275 or my turbo engine. I'll give you a nice breakdown of how everything feels. So really exciting stuff. Thank you guys so much for joining me. And until I see you on the next one, you know the drill. Enjoy those minis and motor on. See you guys.